Awesome. Okay, cool. So we're now recording. So today's lecture is going to be focused on two key things. It'll be hopefully a lot shorter than future lectures because we want to keep today as like a relatively relaxed, chill day. So we're going to start by talking a little bit about the command line, and then we're going to transition over to Git and GitHub. So before I get started, can anyone tell me in your own words what the command line is? Like if you had to explain it in like 15 seconds, what would you how would you do that?
A shell or interface to access all the files of your system.
Yeah, that's a pretty good explanation. So basically a command line interface is something that lets you access, the files, whether that be like, Word documents or executable files or full-on applications inside of your computer. It lets you go through a bunch of different folders. You can put stuff in folders, you can organize them, you can make new files, you can copy them, you can access hidden files. It basically takes like your traditional file explorer that we see here on that graphical user interface or GUI on the left, which is what we're all used to, and turns it into something that's a little bit uglier, but as we'll see, is far more helpful for programmers when trying to work on different files. So let's go ahead and see what an example of a command line looks like. So this is my shell in WSL. Most of you guys, if you're on Windows, you'll see that, or on Linux, you'll see a shell that looks very similar. If you're on Mac, it'll probably have a few more colors, but it's basically the same thing. Um, so when you first open up WSL, you should see a prompt relatively similar to this. Obviously, some parts of this will hopefully be different unless somebody else has a duplicate of my machine, which would be really weird. But to break down, the first thing that you see on the shell is going to be your username, like whatever user you're logged in as, what computer you're on, and then this part here is going to be the directory that you're in. So let me step back one directory and here we'll just clear the terminal. So the first thing that I usually like to do whenever I go into a shell is figure out what's in my home directory. The way we know it's the home directory is because of this tiny little squiggle here. So to find that out, we can type dir, and we see here that I've got a series of 4 folders. I've got one for demos for the previous cohort, for this cohort, and my files, and then a cybersecurity challenge. So let's say, hypothetically, that I wanted to click this folder. Now, if we were doing this in a GUI, like the one over here, all I'd have to do is double click on the folder. Unfortunately, this is a shell, which means it's number one, a lot uglier, and number two, we can't really double click things. So what we'll have to do instead is manually say that I want to change directory. And the way that we change directory is by literally saying cd and then typing the name of the directory you want to go into. So we're going to say demos. And also if you use tab, that will autocomplete a line. So when I say cd demos foxtrot, what this will do is take my little guy here, which you can sort of think of it as like a cursor in your file tree, and move yourself into that folder. And we see that now because the squiggly line here has moved to be squiggle slash demos foxtrot. You can kind of think about this as being the same thing as sort of going like C users on Baba home demos foxtrot. It's basically the same thing. Now, let's say hypothetically that I wanted to go back from my demos folder into my main directory. To do that, we just type cd, change directory. But whereas to change directory, like to go forward and like enter a folder, we have to type the name of the folder. To go back out of the folder, we just use a space and then 2 dots. And then that'll take you right back out to the original directory that you were in. So let me just go back into my demos folder. And here now we can keep this open. And let's see what's inside. So if I type dir, which shows me, a directory, directory doesn't show me anything. Well, that's also probably because I just made the folder 15 minutes ago, and we haven't actually put anything inside it. So let's do that. Does anyone know how to create a file in the terminal? If not, that's okay. We're going to go over it in like 10 seconds.
Touch.
Touch, perfect. So here, actually, I think I've got a slide about this. Let's see. Oh yeah, before we do that, we could probably also talk about what we can do with the command line. So as it says here, you can add folders, you can remove folders, you can list the contents within a folder, you can add a file, you can remove files, you can navigate to other folders. It's great. So these are a list of some of the most common command line tools that we can, or actions that we can use. So as you can see here, they're broken down into two types, like ones that do things to folders and ones that do things to files. There are other ones that are different and that act more generally or more specifically, like for example, if you run Python and then the name of something, it runs that specific script. But we won't get into that today. That'll be a topic for later this week. So to start off, why don't we go ahead and create a new file? So I'm going to say touch, let's just say like test file, and I'm going to add on an extension and call it a .txt file. When I do that, it doesn't look like anything's happened. But if I type dir again, we see that test file.txt has shown up inside of my demo's Foxtrot. Okay, that's great. Let's see, what else can we do? So we can touch a file, we can let's see, why don't we can also try creating a folder within this. So whereas touch can be used to create a file, we'll use mkdir or literally make directory. We can just say like test folder. And again, we can do dir, and we see here that there's two things inside of our demos folder. We've got that test file that we just created and our test folder. Another thing that we can do instead of dir is we can type ls. For our purposes right now, you can think of dir and ls as doing basically the same thing at a high level, like they're just listing all of the things within your folder. But there are some interesting things that we can do with ls. So if I were to type, for example, ls and then a dash, and the dash is basically going to give us options for running that command. Let's say that I type in ls-a. So we see here that we see a couple dots. Those say how far or we can go back or how, if there are any hidden files. There aren't any hidden files within this folder because, again, it's a brand new folder. It's basically empty. But if I were to go back a level and do the exact same thing, we see here there's a lot more hidden files. So the first time that I ran dir in my home directory, it only showed like 4 folders, and that was it. Now, if I do ls-a, which again shows all the hidden files, all of this stuff is all hidden. So it's whenever you're like downloading a repository or opening a new folder, it's always never a bad idea to see what sorts of hidden files are in your main directories. So we can also do ls-la, and that adds in a bunch of information about the files that are contained in your directory. So for example, let's see, these just talk about let's see what's a good thing we can go over. Here, we'll do the demos Foxtrot one. So it's basically says, the user that it's assigned to. It talks about the number of bytes that are assigned, I believe. It talks about basically the created date and time. And this also talks about the different permissions that can be assigned to it as well. So, for example, the R, W, and X all change for read or stand for read, write, and execute. So this first number 3 here, the RWX says, as the user that I'm currently signed in as, I have permissions to read to the folder, aka like open it up and see what's inside it. I have permission to write to it, aka change things that are inside it, and execute, or if I have an executable file like a .exe, like Chrome or something similar, I can run that inside of my folder. So you probably won't really be using ls or like the -a or -la parts of it, but I always think it's a nifty tool just so you can explore a little bit more of how many cool things the console and command line can show you that you just will not see if you go into like a folder view, like we did before. So let's see what else we can talk about. All right, so we did make dir, we did touch, did see the, yes, we should also talk about how to remove things. So again, you can use clear to clear your terminal. Very, very helpful, especially when you get to like times when you're running like have a bunch of different lines in your terminal and you don't want to see all of them. Clear works magic. So let's see. Yep, so we've got remove dir and r. Okay, so let's go back to our dir. And here we've got, our test file.txt, and we've got our test folder. Oh, one thing I should probably mention. I'm assuming that most of you guys, if not everyone, is using VS Code as your editor. This thing, if you're not, highly recommend downloading that and getting that started. So one thing that we would probably like to do is figure out how to get something from our terminal into VS Code and vice versa. So in order to do that, we literally just type code and then the name of the thing that we want to open in VS Code. So here I'll open up test file. We'll give it a second. Okay, maybe a little bit more than a second. And there we go. So this test file in here is the same thing that is the test file in wherever we were in our terminal, in this case in the demos Foxtrot folder. So again, in order to open that up, you want to use code and then testfile.txt or whatever the name of your file is, and that will open up the file that you want in VS Code. Additionally, let's say you didn't just want to open up one file. Let's say that in my demos folder, like I have 40 different files for a project I'm working on, and I want to open up everything. How can I do that? Well, the easiest way is to go into that folder and then just say code and then dot. And what that will do is it'll open up that folder that you're in sort of as like a working directory. So give it a second. And as you can see, here, let me make this a little bigger. It says that I'm in the demos Foxtrot folder, and these are all of the different things in it. So I've got my little test file, and I've got my test folder. So that's a very quick overview of how we can use VS Code along with your shell commands. So one or two more quick things, and then we'll move on to a very brief overview of Git and Git controls. So again, we've got these two little things in here. We've got our test file and our test folder. Why don't we go into test folder real quick, and I'm just going to create a new file called misc file, make sure that it's actually created in there. Okay, so here, let's go back here. So we now have a test file, a folder, and that folder contains this miscellaneous file. Let's say that I want to delete a file. Like I don't have any need for testfile.txt anymore. So we can just type remove, or remove doesn't exist, but you want to type rm, and then we'll just say testfile.txt. It doesn't give us an output, which is good because it didn't throw an error. And we can type ls, and we see here that that test file has now disappeared. Now, let's say we wanted to remove a folder. I can also try doing remove test folder, but now this time we get an error. It says rm cannot remove test folder. It is a directory. So in order to remove a folder, we have two options that we can use. One of them is rmdir, or quite literally remove directory. And the other one is going to be rm-rf. And what this will do is it will recursively go through the folder, or essentially like go into the folder and then the subfolders and then the subfolders of the subfolders and like clean out the folder that we're looking at from the inside out. So if we were to run this on test folder, and now we list it, we see that there's nothing inside of demos Foxtrot. So again, the reason RM doesn't work is because RM is designed to remove an individual file. You can't use that for a folder. If you want to completely delete a folder, you can either use rm-rf or rmdir. Either one is acceptable. Let me go back to that presentation and make sure I haven't missed anything. Yeah, that's pretty much it. So again, these are like the 6 big commands that I recommend. If you don't memorize them, that's okay. like have them on a sticky note. It's never hurts. But these are like 6 of the most used command line tools that you'll see. Any questions about the command line before I move on very briefly to GitHub and using Git?
Did you maybe want to talk about the danger of RMRF?
Um, I guess one possible danger of RMRF is check the directory that you're in. This also just goes for working in the command uh in the shell or command line in general. But whenever you so full disclosure, like if I were to open up a brand new window for WSL, you'll see here that it opens up in this little squiggly line directory, which is essentially my home directory. So on all of your guys' computers, it will also open up in the home directory for your user. Please do not type rmrf in this directory because trust me, I have seen this happen before. Your entire a good amount of stuff on your computer will essentially get wiped out if you do that because this directory is the directory that contains like your files, your desktop, your downloads, like the whole shebang. So whenever you're operating in the command line or the shell in general, always make sure of your directory, again, by checking, the thing that comes after the squiggle line or the home, to make sure that you're not in a place where you shouldn't be. Um, I'll give the same comments for when I get to GitHub as well, because it happens probably a couple of times a cohort that somebody is in their like home user directory and they end up either deleting a bunch of files from it or pushing up their entire computer, like literally their entire computer up to GitHub, as in all million something files. And we'd like to avoid that. So whenever you're operating the shell, always just triple check what directory you're in. That's my best word of advice there. Does anybody have any questions about command line or any of the functions that we talked about before we move on to Git? Okay, great. Well, if not, so number one, this presentation is on our GitHub. So it's literally the underlined or the hyperlinked the command line lecture. If you guys want some practice with the command line, which I highly encourage, especially if you haven't used it too much before, there's a nice, helpful like 15 mini exercises in here that I recommend going through, just because again, it doesn't hurt just to make sure that you've got that down. And this will be especially important, number one, when we start running files and making more complicated directories over the next few weeks. But also, this is super important for when we jump into Git and GitHub. So here, if you go back here, you'll see that we've got a Git resource page. That's what I'm gonna be loosely following if you guys want to follow along. So first off, GitHub is a place that contains, projects, and more specifically, it's used a lot for version control. So for example, if you're developing a website, you're going to publish the website itself once it's complete. But just like if you're working on like, a Word document or something on your computer, you're going to want to save backups of it somewhere. So that way, if something gets corrupted or doesn't work, you can always go back to an old version. That's basically what GitHub and Git are really, really helpful for. They're good for saving versions, sending your versions to other people, letting other people download those versions. That is basically like the number one thing that we use Git for. So this repository, or basically place where stuff lives, is a repository. It's a good example for how we will be using Git a lot in this cohort and also just in general. So whenever we get a repository, in general, we do not want to just take the code and then pop this in our console and basically download the whole thing. We usually want to try making our own version of it, or as it says here, we want to fork a copy. So in this case, what I'm going to do is I'm going to click the fork button. It says, okay, this is me. This is the name of the repository. We'll just call it Git Resource Demo. Yep, we can copy the main branch and we'll hit create fork. And what this will do is it's going to create a copy of the whatever thing I was just looking at, and put it on my account. So as you can see here at the top now, it says that this is under my GitHub username / the name of the repository. But if I go back to the original one, which is up here, we see that the original one is part of Foxtrot Platoon evening and weekend. So whenever we're going to be doing this a lot for homework, like every single homework assignment that you do will require you to create a fork. So it's good to keep how to do this in mind. Now, once you do that, the next thing we're going to want to do is figure out how to put this wonderful thing from just files living in GitHub to files on our computer. And to do that, we're going to be using the git clone feature. So hopefully, if this hasn't broken, let me just clear the console and list things. We don't have anything there. Beautiful. So we're just going to type git clone and then paste it in. And let's see if this will work. Oh dear. Okay, I just had this problem earlier. Okay, here, we're going to pause the recording for 2 minutes because I know how to figure this out, but it takes a second. And resume the recording. All right, great. So again, to recap, the problem occurred previously, which was, oh boy, yeah, up here. Because it apparently did not like to authenticate using a password. So this is number one, why you should always save your authentication in a cache. There are some helpful guides on how to do that on the GitHub docs and Stack Overflow. But the way that you can do that once it's done is by running this line here that basically says, hey, for the git config, which is on your computer, to set the credential helper as cached. So that way it hopefully will remember your authentication token. If it doesn't, the good thing is you can find your authentication token in your GitHub account. So all is not lost. Okay, anyway, now that's done, what we should, if you guys are following along, which you're welcome to, at this point, you should have been able to fork over the Git resources module from Foxtrot Platoon by clicking the fork button and making your own copy of it in your account. Again, we're going to want to go through that for every single GitHub related thing that we're going to be working on, especially for homework, for your assessments and projects later on. This is the formula that we're going to follow. And then we're going to go to code, copy the URL, go back to your shell, and then we're going to git clone this into our shell. So what that does is it'll essentially ask you for your username and password, or ideally it shouldn't once everything's cached. And then it'll count how many objects are in this GitHub. So we've got the .github here that has 3 things. We've got this Git project that has 1, and it comes up with 1 or 2 more. I think there's probably a git ignore and 1 or 2 other files in there. And it says that there's 9 objects. It's going to count them. It's going to compress them onto your computer. And it's going to put them on your computer in a folder. So how can we see that? Well, we can go back to use our handy ls tool. And we see here that it's now created a folder for me called Git Resource Demo. That folder was not there before. The only reason this folder has been created is because we ran this git clone operation. So let's go ahead and change directories into Git Resource Demo. And let's go ahead and see what's inside. Okay, so we have our README and we have Git project. So let's go ahead and see what's in our README. So I can use cat to figure out what's in the README. And as we can see, this README is like super long. I don't want to use this entire README. In fact, I don't like the look of this README at all. So what I'm going to do is I'm going to enter into VS Code. Hopefully it will open up in just a second. And I'm opening up the folder in VS Code. So I'm in my Git resource demo folder. And I'm going to delete this entire README just on my own, for no apparent reason. And we're just going to say this is a sample README. So I'll just save it very quickly. And if we go back to the original thing that I've saved, the README here on my GitHub has not changed. But on my computer, the README has changed. Here, let me close out of this. Welcome VS Code. We don't need that. So at this point, ostensibly what I want to do is take the changes from my local machine, namely deleting the entire README, and push it up to my GitHub. I want the thing stored on GitHub servers to reflect the thing that the changes that I've just made. So here, let's see if, oh, that's not the one. README, there we go. So the way that we can do that is by, number one, adding or staging our changes, and then committing our changes to GitHub. So let's go ahead and do that. So number one, the way that we know if something's changed, or the handy way we can tell that in VS Code, is if you can see these three little dots here, which we're not going to go over how to use that today, but probably in a couple of weeks from now in one of my Monday lessons we will. But if you do that, you see here that there's a changes button or a changes field. And that says that the file that was changed was readme.md. And it says here that it's been modified. I can click it and I can see exactly what modifications were made. Namely, I added a line and I deleted everything else. So this is a handy way inside VS Code to check what files have been changed before you push before you commit something on your GitHub. So the next thing that we can do is add our changes or stage them. And we'll do that by saying git add, and then the dot. The dot is just going to basically say that we're going to add all of our stage changes within Git resource demo. And then we're going to be able to commit all of those. So the next thing that we should do is probably commit our changes. So we'll do git commit, say -m, and we'll just say modified readme. Oh, there we go. And now we see here, it says that the main branch has modified the README. Here are the changes that happened. We changed one file, which was the README file. It has one insertion and 60 deletions, and we rewrote readme.md. So any questions about what I just did before we do the last thing? Yeah, go ahead, Katja.
Not necessarily about the process itself, but just a curiosity because I have actually never forked before. This is completely independent from the original repository, right? So when you push, it would have nothing to do or any changes at all from the original one. Okay.
Exactly. And that
Thank
is
you.
the precise reason why we do a fork. So, let's say hypothetically that I didn't fork over the original thing. And I, was playing around, making a bunch of changes, completely corrupted 15 files that I can never change back. And let's pretend that, I messed up when doing git add and git commit, and I didn't notice that those 15 files were corrupted. And then when I do git push, which is going to push it up to where it was originally, if we didn't fork it, those 15 corrupted files would now be in the original place, which is really bad. So by forking it over to a copy of your own machine, or if you want to be a little fancier, by forking it over to a brand new branch, which is a concept that we'll get into more later, it essentially protects the master or the original Git repository from being changed until you go ahead and verify everything. So right here, what I've done is a git push, and I can show you exactly what happens. So it's not going to like refresh the repository automatically until I hit the refresh button. And ta-da, look at that. Our glorious 60-line README now has 1 line. But to make sure that those changes do not go over to our original one, I can just hit refresh, and the original README is still there, which is exactly what we want. I only wanted to change it first on my local machine, then on my fork, and I did not want to change, not the GitHub website, I did not want to change anything on the original Git resource page. The last thing that we're going to do is, let's say hypothetically, I did want my changes from, the local branch that I've created from my fork. I want those changes to be incorporated in the original. The easiest way for us to do that is by adding something called a pull request. So as you'll see here, it says they help you collaborate on code with other people. Essentially, it gives you a way to control the version of the original thing. So I'm going to go ahead and say, hit new pull request, and see, we should be able, contrary across forks. That's what I wanted to do. So I'm going to go ahead and add my repository as a head repository. It says that these branches can automatically be merged, which is good because sometimes you will have a merge conflict, which I won't talk about today, but that is something to keep in mind. You'll see here that it shows me my commit, which says that I modified the README and all the changes that happened. So let's see, where's the green button? Create pull request. I can just add a description, and then there's a nice little autofill form. I can just say, Omer, there was no one else. Summary of solution, made a better README, questions that came up. Why was my README so short? So this essentially just adds in, some comments for whoever's reviewing your code. For some of the exercises that are coming up, you guys will be making use of this. And then we'll just hit create pull request. We'll give it a second. And the important thing to notice is if I go back to Git resource, this still has not changed. So by making a pull request, you are not changing the original thing automatically. However, somebody else, like the person who owns the original thing, like Git resource, they can go to your pull request and they can choose to merge pull request, which would then make my edits permanent in Git resource, which I'm not going to do. Or, they can, instead of merging it, they can, let's see, they should be able to, they can add comments and ask somebody to submit another pull request, etc. So the main flow that we're going to be using whenever we do basically anything with GitHub, the first thing you want to do is make a fork. The fork is going to go into your own account, not the other person's or the organization's. You're then going to use git clone to clone it down, which is somewhere in here. Once you use git clone, you'll use VS Code to open up your Git repository on your computer, go through, make whatever edits you need to, add your changes by using git add, and then whenever you're ready to push your changes up, you can do git commit, add a little message, and then git push, and git push pushes everything back onto your repository owned by you, and then we can use a pull request to get it back over to the other side. It sounds a little complicated initially, but the easy way to remember it is like fork it over, clone it down, change your stuff, commit, and then pull it back to the original. Trust me, you're not expected to memorize this process by any means. I know for me, it took probably like 3 weeks before I was able to memorize the steps without having a bunch of errors. So what I always recommend is follow this cheat sheet and also like write down the flow, especially as you go through it the first few times. I'll write it down and send it in the Slack as well. But just make sure every time you want to be following the exact same steps every single time we go through anything related to Git or version control. And my biggest word of warning that I will give is check your directories when you're using Git. Just like with RMRF, you don't want to remove your entire computer. If I were to do, let's see, I'll hop directories one more time, and I'm now in like the home directory. Here, let's see if I can jump back one more. So I'm in this directory that has a bunch of files that are like very high level files. Like this is, stuff that's within the WSL shell. Imagine that this was like the main directory of your computer. What you do not want to do is be in this directory and do a git push, because that will literally push your entire computer up to GitHub. And that process can be difficult to stop because it's millions of files getting uploaded. This happens again, usually about once or twice every cohort, but somebody's computer will get extremely severely lagged, not to mention also their GitHub getting really laggy. So always, always, always make sure that you're checking your directories before doing any operations. Like being in your home directory versus being in a folder is super important, and I can't like underscore that enough. Yeah, that's about it for lecture tonight. So does anyone have any questions, comments, concerns before we get you guys started on your first homework assignments?
Yeah, quick question. Is the pull request only done within GitHub, or do we do like hub pull requests in the CLI?
Question. Usually I like to do it on GitHub itself, just because it's a cleaner interface. You have big buttons, like it just looks a little bit neater. That being said, there's nothing wrong with doing it through the CLI. I mean, that's why we're teach everything starting with the CLI, because it's the most base way to do it. And, you learn more by doing that. So if you want to, you can. Out of personal preference and also just ease of reading things, I prefer to do it through GitHub, but either one is totally fine.
Cool.
Any other questions? Okay, so I'm going to go ahead